outside. Maybe I'll build a fence. Maybe I'll take a walk around the block. I need to find the distance around the outside. That's good. Perimeter's the outside. We just add. It's all around the outside. It's good. Perimeter's the outside. Area means the inside. Cover the surface that's inside. Measure the length and measure the width, and then you multiply. Well, maybe I'll buy a new shag carpet, or maybe I'll make a quilt using squares. I'll just make sure I multiply the length by the width, find square units inside. It's the area. That's good. The area's the inside. Multiply. The area's the inside. It's good. Square units on the inside.
Well, geometry students, welcome back to another lesson. We're in 1.4 here in Big Ideas. Perimeter and area in a coordinate plane. So we're going to be looking at definitely the perimeter, the outside, the area around the outside, so what's on the outside, and then the area, which is this stuff, what's on the inside of a figure, of a polygon. And we're going to be classifying polygons today. As we, before we get into perimeter area, we'll look at those first. But before all that, let's just take a look quick at a cartoon of the day here from this is In the Bleachers. So it says, another motorist fails the field spiral test. You may be familiar with the field sobriety test. When somebody gets pulled over for like drunk driving, they give them a field sobriety test where usually you got to walk a straight line. But here is a motorist having to do a field spiral test. And one officer saying, "I'm sorry, sir, that pass was really wobbly. Please turn around and put your hands on the back of your head." Because he can't throw a spiral. All right, well, moving into our lesson, here we go. Car concept on page 19 shows us polygons. So here's where you want to highlight some things in this, because there's some vocabulary in here. You don't have to write it down on the vocabulary, just go ahead and highlight inside here. It says, in geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. And so here's an example of a polygon, a closed figure. And so it's got 3 or more of these sides here. And this one actually has 5 sides. So that's what you want to kind of put down. You want to kind of highlight these things in here. You can underline, that polygon is a closed plane figure formed by 3 or more line segments, and those are called sides. Each side exactly extends, so each side intersects exactly 2 sides. So that's what's going to happen. So it's like this side here is intersecting this side over here and this side over here, exactly 2 sides. One at each vertex. So that vertex is the corner point. And, so you can kind of see where this is. So that no 2 sides with a common vertex are collinear. So you're not going to be collinear. So this side here is not going to be collinear with DE down here, because it's going to turn. As soon as it hits a vertex, it turns. And you can name a polygon by listing the vertices in consecutive order. So here's how we can name this polygon right here. Polygon A, B, C, D, and so you list them in order A, B, C, D as you go around. And you could probably go, even different ways. You just got to list it in order. Start from one spot and go around one way or the other way. Typically, we try to do it in alphabetical order as best as possible. All right, moving into the next part here, we're going to stay on page 19. We're going to copy this little chart here in the vocabulary section for the n-gon term. So you don't need to really write anything for n-gon, but just copy this chart. So that's what you're going to actually write for n-gon. So we have numbers of sides and the type of the polygon. So it says the number of sides determines the name of the polygon as shown in this table. Now you can also name a polygon using the term n-gon, where n is the number of sides. For instance, a 14-gon is a polygon with 14 sides. As you notice, we only really have names up until 12 sides. Past 12, we would just call it whatever number of sides it has, that gon. So like it says here, 14-gon is a polygon with 14 sides. So go ahead and you can pause the video right now and just copy this into your notes. 3 sides is a triangle, 4 sides is quadrilateral, 5 is a pentagon, 6 sides is a hexagon, 7 heptagon, 8 octagon, 9 is nonagon, 10 is decagon, and 12 is dodecagon. So you can see there's a gap there for 11. So if we do have an 11-sided figure, we would call it an 11-gon using the number like 14 here. Okay, you go and pause the video and finish copying this and then go on to the next part. Okay, which our next part here now is to copy this also in the vocabulary section. That's going to coincide with the vocabulary words of convex and concave. So it says here, a polygon is convex when no line that contains a side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is concave. So here's an example of a convex polygon where it's one that's like this. So if you were to draw a line over, through each side where you just basically, extend it all the way out. So like it's in black here, the figure, but then the red line goes over that side and it just keeps extending. Notice it's not going in through the polygon anywhere. This one is only staying on the outside of this polygon the entire time. But for this one here, this one's concave. So here's our interior. If you look at this little segment right here, if we drew a line, it's going to end up going through the interior of the polygon. So that is not convex, it is actually concave. In fact, I think it's easier to see the concave ones just by looking at it, because you can see there's the cave right there. This is caved in. This polygon is caved in right here. And you can see, okay, there's no caves in this one. There's no cave-ins anywhere throughout anything. So basically, this vertice right here is kind of a caved in, a concave vertice right there. So that's kind of an easier way to maybe see it. So make sure you copy these two figures down here in the vocabulary section where you have that. And if you want to write some of this down, you can write that down as well if you want to remember it, but mainly copy the figures. The pictures are sometimes even better than the actual words in the definition. You want to know the pictures. So go ahead and pause that and finish copying that, and then you'll be ready to go on to the next part. Okay, so our next part is actually just trying to figure out the names of these polygons and if they're convex or concave. So let's start with these ones here. Just take a look at them. So take a look at letter A. To figure out how, what do we call this? Classify the polygon by the number of sides. Well, you got to count the number of sides. So think about, okay, count those for me. How many sides do you see? You should see 4 sides. So on your chart that you just wrote down, when it says 4 sides, what do we call it? Well, it's called a quadrilateral. And then also, is it convex or concave? So do you see any caves in this one? Yeah, there's one right here. See, this vertice right here is a caved-in vertice. So that would be concave. So it is a quadrilateral and it is concave. B, what do we classify this as? What polygon name do we give it? So count the sides on this one. So if you count all these sides, how many do you see? 1, 2, 3, 4, 5, 6. So there are 6 sides. What do we call a 6-sided polygon? Well, that's called a hexagon. And then are there any caves in this one? And there's nothing. There's no caves here. All the vertices are kind of poking outway. So there's nothing that's caved in. And so it's a hexagon and it's convex then. So if it's not concave, then it would be convex. So sometimes it's easier to see it as a concave, but if it's not concave, we need to remember the word convex. Here's a couple other ones. Go ahead and try these. Think about these here. I'll give you a moment to think about what you would call number 1. And is it convex or concave? Okay, so here's what you should have figured out. If you add all the sides up, you definitely see it's concave right there. And the name of this one is a pentagon. There are 5 sides, so we call it a pentagon. It's concave. So think about number 2, what you would call that one, and if it's convex or concave. So if you add all these sides up, you can definitely see it is not concave, which means it's convex, because all these vertices are poking out. And if you add all the sides up, it's a heptagon. You call it a heptagon because there's 7 of them, 7 sides, and so it's heptagon convex. All right. Moving on to our extra. Okay, so on to the extra practice here. We have page 20, and I'm going to give you some time to do 1 through 4. So you're doing the same thing, classify the polygon by the number of sides and tell if it is convex or concave. So go ahead and pause the video at this point and work your way through 1 through 4, and then play it, and then you can check to see if you got these correct. Okay, so hopefully you pause the video, and now you're just checking to see if you got these, classifying the names correct and if it's convex or concave. So number 1, we definitely, if we add up all the sides, we got 1, 2, 3, 4, 5. So there's 5 there, and then it's also definitely got a cave in it, so it's definitely concave. So it's called a pentagon because it's 5 sides and it is concave. Number 2, you can see, count up all the sides here, 1, 2, 3 on top, 4, 5, 6 on the bottom, 7, 8. So it's an octagon because there's 8 sides and there's no caves in this one. So it's an octagon and we call it convex. Number 3, we got 1, 2, 3, 4, 5, 6, 7, 8. So 8 again on this one almost looks very similar to this one, except this vertex is like pushed down, so it's definitely caved in. And so it's also an octagon, but it's concave on that one. And this one, definitely convex, no cave-ins anywhere. And this one, you got a lot of sides on this one. There are 12 of them, so you'd call it a dodecagon. So if you counted that correctly, you counted 12 sides, calling it dodecagon, and it's convex. Okay, so now continuing on with our extra practice right there, number 5. 5 through 8, in fact, say find the perimeter and area of the polygon with the given vertices. So we're going to first plot these points and make a shape. And these are going to be triangles here because there's only 3 vertices. So once we plot those and get the shape, then we want to find the perimeter, which would be the around the outside, the distance around the outside of the figure, and then we also want to find the area of the polygon, which is the space on the inside in square units. So go ahead and, let's see, number 5, go ahead and plot these points. Maybe we want to pause the video and plot the points. You can pause the video and plot the points for both 5 and 6, and then play it and see what we have. But go ahead and definitely plot X, Y, Z here, get a triangle, connect the dots, connect these together to get your triangle. Okay, so hopefully you have a triangle for number 5, and that triangle should look like this. I put the coordinate plane down there according to where you should maybe plan to put it, and then each one of these is worth just 1 unit here. That's all it is, just 1 unit. And so hopefully your triangle looks the same size as mine here, and that way we can go off of these units. And so to do this, to find the perimeter, we need to find the length of each side. So these 2 are very easy. Now we've done these a little bit before, where we found this triangle perimeter, or even just the length of each side. So we have this side right here, so we can see what XZ is, and then what YZ is. So XZ is 6. If we count that, 1, 2, 3, 4, 5, 6. And then YZ is just 2, so those are easy to get. The harder one is going to be XY. We're going to have to use the distance formula for this. So that distance formula we're going to keep using over and over and over again whenever we need to find the distance between 2 points here. That's not going to be on a nice easy line to just count. We can't just count here, so we have to use our distance formula with points X and Y. So that's these 2 points right here. So our distance formula for that to find X and Y, we'll start off with subtracting the X numbers, which would be 2 minus 0. So 2 minus 0, and we've got to square that. We're going to add it to subtracting the Y's, 4 minus a negative 2, also in there, which is a minus a negative is going to turn to a plus 2. So it's going to be turning to a positive. That's why it's positive, because we have minus and 2 is negative. 2 negatives make the positive. So in our first part, that's just going to be 2 squared, and over here it's 6 squared. So now we got 2 squared plus 6 squared. So that's going to be 4. That's going to be 36. So 4 plus 36 then, underneath the square root sign, becomes the square root of 40. Now we need to make this into a decimal, so we want to, it doesn't say necessarily to round this to any particular one. If it doesn't say to round to anything in particular, so when we do the square root of 40 right here, we're going to get 6.32. I would just always go to 2 decimal places if it doesn't tell you what place to round it to. So if it doesn't tell you what place, go to 2. Just kind of default always to 2 places. Sometimes it might say tenth, sometimes hundredth, sometimes even thousandth. That'd be 3 decimal places. But if it doesn't say, just default to always 2 places. I think that would be best. So that would give us right here 6.32, and then we just got to add up our sides. So 6 plus 2 plus 6.32 would give us a perimeter of 14.32 units. Then it wants us to find the area. Now to find the area, we have a formula for that, which is area equals, on a triangle, it's 1/2 base times height. If it was a 4-sided figure, just like a regular rectangle, then it's just base times height or length times width. Just multiply. Even just like that video is saying, you're going to multiply definitely, but when it's a triangle, you got to multiply the base and the height times 1/2, because really you have 1/2 of a rectangle right here. If you extend it over to here, here's the other half of the rectangle, which is exactly the same triangle as what we have here. So now our base and height are the numbers that we know already here with 6 and 2. So we can just plug those numbers in. And so 1/2 times 2 times 6. And well, half of 2 is 1, so it's just going to be 1 times 6, which is 6. Or you can say multiply these and get 12. Half of 12 is 6. However you want to multiply these, you're fine. You just need to end up with 6, and it's square units. So whenever you do area, just remember to always say square units. If they actually tell you the units, like centimeters or inches, then you can say inches squared or centimeters squared or feet squared or something like that. But if they don't tell you what units, if it's just on a coordinate plane like this, then just put square units on there. Okay, make sure you have plotted P, Q, and R on here. Make your triangle. If you haven't done that, go ahead and pause it and then play it once you have your triangle down. Okay, so hopefully you got P, Q, R plotted down here, and they're just, every one is 1 unit again, and so that's going to look like this here. So you have your P, Q, and then R is over here in quadrant number 2. So to find the perimeter, this one's easy to find. PQ is very easy. That's just 2 units. So PQ, simple. It's the other 2 that are going to be a little more challenging. So P to R and Q to R, those are actually going to be the same length. They are the same length. You can see that because they do have the exact same slope to get to that point. So they will be the same length on those. I just need to find one of them. And so we're going to have to use the distance formula then to find. I'll just use RP. So R and P, these 2 ordered pairs here. You could have done it with Q and R, these 2 ordered pairs here if you wanted to. It would be the same thing. So to subtract these ones, we're going to start with subtracting 1 minus -4. I'm going to do P and R. So 1 minus the -4, that'll be a double negative there. And then 3 minus 2 for the y's. And so in this one, double negative, it's going to turn to a 5 squared, and then 3 minus 2 is 1 squared. So 5 squared plus 1 squared. So that's 25 plus 1. It's inside here. 25 plus 1 gives us the square root of 26. And again, we need to find the square root of that. So 26 square root, and it's 5.09. I would just go now, we're going to say, round this up, which would be 5.10. Or just on this one, since it's going to be 5.10, you can just say 5.1 then. So it's going to be 5.1 if we round it. And so now what we can do is they're both going to be 5.1. So what we're going to see is, as we're finding the perimeter, it's going to be 5.1 plus 5.1 and then plus 2. And that's going to give us a perimeter of 12.2 units as we add these up. So there's our perimeter. That's the distance around the outside. And now as far as the area goes, again, we need the area formula, the 1/2 base times height, but now we may know that the PQ is the base, but what's the height? We're not going to use these sides here. The height actually has to be a right angle from the point up here down to this side. So that's got to be a line going straight across. So we have this straight line right here. That's our height, which that's easy to figure out. We can just count for this line. 1, 2, 3, 4, 5. Our height's going to be 5 where the base is 2. As long as you use this being the base, you can use the height right here because that's going to be at a right angle. And so we plug those in. So 1/2 2 times 5. And so we can take half of 2. And that would just be 1 times 5, which is 5. Or you could say 10. And 10 times 1/2 is 5. So as long as you get to 5 square units for that triangle, you're good. All right, let's move on to the next two. All right, so on 7 and 8, you're noticing this one we have one extra ordered pair. So this is going to make a quadrilateral, a four-sided figure. And so the first thing to do again is just plot those points, J, K, L, and M. Go ahead and plot those points. You can pause the video and plot those. You should get a rectangle when you plot those points, and just make sure each one is worth 1 unit. And as long as you draw the coordinate plane the way I have it drawn here, draw it on the 4 units this way and right across the middle here. That way everything fits in there right. All right, so hopefully you've plotted these points. If you didn't, pause it and plot them and then play it again. But this is what it should look like once you've plotted those points. You get a rectangle in here. There's J, K, L, and M. And we want to find again the perimeter, which is just the distance around the outside, and we also want to find the area on the inside in square units. So again, for the perimeter, we can just add up the sides. That's one way we can do it. So we need to know what is the side length. So from J to M and L to M to L. So the first one I got there is that this is 10. So from J to M, if you add up this or just count, you got 10 boxes from J to M. K to L is the same thing. So these two are going to be exactly the same. M to L is just 3. So you could say, well, 10 plus 10 is 20, and 3 and 3 is 6. So that's 26. Another way you could do a perimeter also is perimeter can be 2 times the length plus 2 times the width. That's 20 plus 6, and that does give you that 26. So 20 plus 6 is 26 units for perimeter. And now for area, when it's a rectangle, it's just length times width. So the triangle is actually a little more involved with the 1/2 base times height, but when it's a rectangle, it's even easier. Length times width, which is just 10 times 3, so the area is 30 square units for this one. All right, number 8, go ahead and plot D, E, F, and G on this coordinate plane. Make sure you draw your coordinate plane the way I have it so everything fits on there correctly. And each box is worth 1 unit. So make sure you plot them and then go ahead and play the video again. Alright, so hopefully you have your points here. You should have made a square. It should look like a square. It should look like this down here. So you have D, E, F, and G. It's a perfect square where the side is 3 on every single one, as you can see. Every side is worth 3 units. So finding the perimeter, 3 plus 3 plus 3 plus 3 all the way around. So, or you can just say 4 times a side. Because there's 4 sides, there's 3 for each side. So that's 12 units for the perimeter. And the area, again, can just be sides squared. So you have a side, you can just square that side. So you can say 3 squared for the area, which is the same thing as saying 3 times 3, like we did length times width here. When you just say when it's a square, you can just do side squared. So that's 9 square units for this one. When it's a square, you can do it this way. All right, let's continue on with number 9. Okay, so I lied. We're not going to go on to the next problem. I wanted to do one more of these find perimeter and area of the polygon problems. And this one I want you to put on the bottom of page 19, right below that core concept with polygons. And you're going to just go ahead and draw your own coordinate plane, x-axis, y-axis, and plot Q, R, S, and T on that coordinate plane. And then we're going to find the perimeter and area of that polygon. It's a quadrilateral, so it's 4 sides. It's going to be like a rectangle. So go ahead and pause the video and plot that down there on the bottom of page 19. Okay, hopefully at this point you have that now completed as far as your coordinate plane and this polygon on the graph. It should look like this with your coordinate plane, and you have the R, S, you got Q and T over here. And notice that you've got a rectangle, but it's kind of sideways. We can't really count on any of these. It wasn't like those last ones where we could just go ahead and count the distance here of each of them. So in order to find the distance of these sides, now QR and TS is going to be the same, and these are going to be the same as well. It is a rectangle, and so these are going to be exactly the same. So it's length times width, but if we were trying to find the area. But we're going to have to use the distance formula to find the distance of these. So first, remember the distance formula. Well, I'll put it down here. Subtract the x's, square it, plus subtract the y's and square it. So let's start with finding QR. So that's the distance of these two. So point Q and point R. So we're going to subtract the x's, -4 minus 1, and then subtract the y's, -1 minus 4. So it'll look like that there. Inside, we're squaring each of those. So we're going to get -5 squared here, and we're also going to get -5 squared there. So it's going to be 25 plus 25. -5 squared is equal to 25. So 25 and 25 make the square root of 50. And we would want to figure out what the decimal form of this is. So find the square root of the decimal. As we do that one, that's going to be 7.07. Again, go to 2 decimal places because it doesn't say how many decimal places to round it to, so we'll just default to 2. So this side, QR, we could say is square root of 50. That's the exact distance. This is the rounded distance to 2 decimal places. All right, let's go ahead and find RS next. So RS, we're going to do R and S right here. So 1 minus 4 first right there, and then 4 minus 1. And so that's going to give us -3 here, +3 here. So they're both 9 when we square them. So 9 plus 9 is 18. So that's square root of 18. And so the square root of 18 as a decimal, rounded to 2 decimal places, is 4.24. So you can find that on the calculator. But the exact distance from R to S is the square root of 18, as you can see. And so then we want to find the perimeter. Perimeter is just going to add up all the sides. So there's 2 of the 7.07s, 2 of the 4.24s. So you can do that 7.07 plus itself, plus 4.24, 4.24. If you add all of that up, you find your perimeter is equal to 22.62. Okay, so now as far as the area goes, area of this would be length times width, which is we should go off of, the best way would be going off of these square roots right here to get a bigger square root. So let me use a different color. So to find the area, which is again just the length times width, so that's going to be the square root of 50 times, put it in parentheses, the square root of 18. And what we can do there, since they're both under square roots, we can multiply those square roots together. Remember, we did that little review before at the beginning of the year. And so to multiply just 50 times 18 gives us 900. So we're getting the square root of 900. And so then so that way it gives us a more accurate, it's going to give us a more accurate answer on this one. So the square root of 900 is exactly 30. So this one is going to be for the area. The area is exactly 30, and we'll put square units again on this one. This would just be units. This one is the square units, 30 square units for that one. So make sure that's copied down on the bottom of 19. You should have had enough space there to do this one. All right, so now back to the extra practice. But before we get to that, let's do a little quick joke of the day. Take a pause here, break. What did one hat say to the other? What did one hat say to another? Well, he said, "You stay here, I'll go on ahead." Go on ahead. That's where you put hats. They're on ahead. Hats go on ahead. Okay, so now here we are with 9 through 14 on our extra practice. This is page 21 now at the top. So we're going to use this diagram over here for 9 through 14. 9 to 11, we're looking at perimeters, and then 12 to 14, we'll look at the areas. So starting with 9, it says find the perimeter of triangle ABD. So when it puts a little triangle in front of some letters, we know it's talking about a triangle. So we look over here at triangle ABD. I think that's the first time we actually have seen that symbol so far. So ABD here. So on this one, we need to find the perimeter. So we're trying to find the distance around the outside of this. So this one and this one are going to be easy. Those ones we can just count. But again, this one we're going to have to use the distance formula for. So for A to B, we can just count that and see that that's 5 right there. From B to D, we can count this 1, 2, 3, 4, 5, 6. So that one's 6 on B to D. But then to find A to D, we're going to need to use our distance formula, so using these 2 points. So we're going to start with the x's, so 2 minus a negative 4. So starting off with that, it's a double negative. 2 minus a negative 4, that's going to change to a plus there. So 2 minus a negative 4 changes to our 2 plus 4, and then we're going to add it to subtracting the y's here. So the y of A is 4, y of D is negative 1. 4 minus a negative 1, we're going to see another double negative as well on this one, minus the negative number. So that makes a positive out of a double negative, so it becomes 4 plus 1 there. And so now we're going to get 6, and this one's going to have 5 in those parentheses. So 6 squared and 5 squared, that's going to give you 36 and 25. So the square root of 36 plus 25, we are going to add those together, and we'll get 61 when we do that. So the square root of 61, we want to now round this to a number here. So if we go to 61, hit the square root button, 7.81, again, default to 2 decimal places. That's usually the best. If it doesn't say anything about decimal places, just default to 2. And so that means that this now is 7.81. So now we can just add up those 3 sides. So the perimeter is going to be 5 plus 6 plus that 7.81. And that all adds up and equals 18.81 units. So there's our answer for number 9. 10 says find the perimeter of triangle BCD. That's this one down below here. So that's this triangle BCD. So far, again, this one we know, 6. But these 2 we do not know. We're going to need to use the distance formula, but we only actually need to use it once because they are going to be the same length. We can see that because they are going, so if you look at right here in the midpoint of this segment right here is going to go straight down to hit that vertice. So that means that this is going to be really an isosceles triangle where these are congruent, really. So we can see that these are going to be the same. They have the same slope, just opposite the numbers. So you can see this one's going to be up 4 and right 3. This is up 4, left 3. So they have the same number slope, just different signs, though. One's positive, one's negative. And so they are going to be the same distance. So let's just find the distance of one of those. It will be the same on both. So let's go for BC. So these numbers here, using our distance from a 2 minus a negative 1. We're seeing a double negative again on that one. So make that a plus. And then you're going to add that to the y numbers of this, of B and C. So a negative 1 minus a negative 5. There's another double negative right there with the minus the negative 5 number. So make that into a plus there as well. So we have in 3 in this parenthesis. Take 1 away from 5, it's 4 in this parenthesis. 3 squared and 4 squared. And 3 squared is 9, 4 squared is 16. So 9 plus 16, that equals 25. So the square root of 25 is exactly 5. So that tells us that BC right there is 5, and I said that this one's going to be the same length. This one's also 5 here. And so now our perimeter for this one's just 5 plus 5 plus 6. And so that just gives us 16 units. For number 11, find the perimeter of quadrilateral ABCD. So that's going to be from A to B, C to D, and back to A again. So that's all the outside of these. So it's 5 plus 5 plus 5 plus our 7.81 number. So for that perimeter, 5 plus 5 plus 5 plus 7.81. So that's 15 plus 7.81, which would equal 22.81 units. All right, let's move on to looking at the areas now. Using the same figure, we're going to now find the areas of these. Okay, so number 12, find the area of ABD, that triangle. It's on top again. And so we need to remember, since we're looking for the area of a triangle, the formula is just 1/2 base times height, or you could think of it as base times height divided by 2. That would be the same thing. So we need a base and a height on this one, so our base was going to be this B to D, right here will be our base. Remember, a base and a height always have to be perpendicular to each other, so they always have to connect at a corner of a right angle. So here's our right angle. This is a right triangle. So basically our legs of this triangle can be the base and the height. This diagonal would be called the hypotenuse of a right triangle. We'll get more into that when we get into looking at right triangles a little more closely. But so 6 is our base and 5 is our height of this triangle. And so when we plug those in, so we start off with the area is equal to 1/2 times the base, 6, times the height, 5. And so 6 times 5 is 30, so it's half times 30, so half of 30 is 15. So we're going to say 15 square units for the area on that triangle. The bottom triangle down here, we need a base and a height. So we can use this 6 here, which is the BD segment, we can use that as our base. Our height would then need to be perpendicular to this base, stretching also from a vertice. So from this vertice, I need to draw a straight line to this base. So that's going to be our height right in the middle, because obviously this is not a right triangle. There's no right angles here. These are all less than 90 degrees. So we're going to say, okay, 6 is our base, and I can draw right here our height, and that's 4 units exactly. So 4 units is our height. So then we could say area is equal to 1/2 times the base, or actually times I put the height first, I guess. It doesn't really matter. So the height times the base, and there you go. So 24 from 4 times 6, 1/2 of 24 is going to give us 12. So 12 square units for the bottom triangle. And then to find the area of the quadrilateral, that's the entire quadrilateral here, this whole thing, we can just say this area plus that area. We don't want to try to find it from the whole thing, but now that we know these two areas, we can just add those two areas together for the whole thing. So the area is equal to the area of the top triangle plus the area of the bottom triangle. So that's 27, not 17, 27 square units. All right, so that concludes our lesson here on 1.4, and you want to go on to doing the assignment from Big Ideas, and I'll see you on the next lesson.